Good afternoon. My name is Sanjay Dhamala, and today I'll be presenting my MSc IT dissertation titled Bus Arrival Time Predictions Using Machine Learning. To give a brief overview of this research, public transportation systems often suffer from unpredictable bus arrival times due to traffic congestion, peak hour variability, and operation inefficiencies. Accurate arrival time prediction is very crucial for reducing passenger waiting time as well as optimizing urban transportation planning. And traditional timetable based systems are static and cannot adapt to real world dynamic conditions. So, to address this issue, this research applies machine learning and deep learning techniques to predict bus arrival times more accurately and precisely using historical transportation data. Moving toward research objectives. The main objective of this research were to analyze historical bus movement data, to perform pre-processing and feature engineering, to develop predictive models using linear regression, random forest, LSTM, that is long short-term memory network, and to evaluate model performance using mean absolute error, root mean square error, and R square, and to compare traditional ML models with deep learning approaches so that in future it can help to improve reliability in public transportation systems. Moving to a literature review. From the literature review, it is evident that machine learning models significantly improve arrival time prediction compared to static schedules. Random forest models are widely used due to their robustness and ability to capture non-linear relationships. However, transportation data has a strong time series dependency. This makes deep learning models like LSTM particularly suitable because they are designed to capture sequential patterns over time. Several studies show that LSTM models outperform traditional machine learning model when predicting traffic flow and travel time due to their memory capability. Based on these findings, LSTM was included in this research as an advanced predictive model. So for this research, publicly available historical transported data was used, and that data set included timestamp data, route identifier, travel distance, travel related variables, weather conditions, seasonal variables. So since the data has the time based sequential information, it was very suited for LSTM modeling. Importantly, no personal identifiable information were included in this data. Um, this research followed a structured pipeline. First, data pre-processing was performed, including handling of missing values and removing outliers. And next, feature engineering was conducted to extract time of the day, peak hour indicators, travel distance, weather and seasonal conditions, route-based features. For the LSTM model, the dataset was reshaped into sequential time series format because LSTM requires input data in sequence form. Then three models were developed: linear regression, that was developed as baseline, a random forest as an advanced machine learning model, and LSTM as a deep learning time series model. Finally, those all models were evaluated using MAE, RMSA, and R square. Linear explaining about the model, a linear regression assumes a simple linear relationship between input feature and output. Whereas random forest build multiple decision trees and aggregates their results, it handles non-linearity as well. Whereas LSTM network is a type of recurrent neural network. It is specifically designed to learn long-term dependencies in sequential data. So, unlike traditional model, LSTM has memory cells that retain past information. This makes it highly suitable for transportation data. where previous traffic conditions influence future arrival time. To ensure objective comparison, two evaluation matrices were used: mean absolute error, which measures average prediction error; root mean square error, which penalizes large prediction error more heavily. Lower the value indicates better performance of the model. The result clearly showed that differences among these models. Linear regression performs adequately but struggled with complex traffic variability. Random forest improved performance due to its ability to model non-linear relationships. However, LSTM achieved the lowest MAE and RMSE values in overall. So this demonstrates that capturing time dependency significantly improves bus arrival time prediction. Therefore, LSTM proved to be the most effective model in this research. Although LSTM performed best, it required more computational resources, longer training time, more complex pre-processing, and the study was limited to historical data without real-time deployment. External factors like roadblocks and accidents that are not included. So this research strictly followed ethical standards. Only publicly available historical data sets were used. No personal identifiable information was involved. All resources were properly cited and results were reported transparently. So in conclusion, this research demonstrates that machine learning and deep learning techniques significantly improve bus arrival time prediction accurately and more precisely, while random forest outperformed linear regression. LSTM achieved the best overall performance due to its ability to capture time series dependencies. So this confirms that deep learning models are particularly effective for intelligent transportation system. For future, this research can be the framework for real-time prediction tools such as real-time GPS data integration can be implemented. LSTM architecture can be further optimized. Weather and accidents data and other roadblocks can be incorporated. A real-world passenger information system like Android-based system can also be developed. So, thank you for listening to my presentation. Thank you.